Hey guys, welcome back to lesson 2.3 about function notation. So today we're going to learn about a way to write a function so that we can differentiate functions from other functions. So we can tell if I've got one function that's supposed to have this rule and another function with a different rule, I can keep those two functions separated. You guys have been used to seeing y equals for a function. Today we're going to talk about a different kind of notation we can use that will help us tell those functions apart. So this is what function notation looks like. So we've seen y equals mx plus b, and we're going to get to that during this unit. This unit is about linear equations. We'll get to that during this unit. But today's lesson is focusing on expressing these as functions. So here's an example of function notation. Right here, so this is going to be f or g or m or l or triangle or 7. Well, not 7 because 7 is a number. But right here, this will be the name of the function. So this will tell me this function is named f. And then this right here in parentheses will tell you what the input of the function is. So right here, this first part, so just this part right here, this tells me I have a function named f whose input is x. So basically x is what I put into the function. What I get out of the function will be this value f of x, this output f of x. Note that this does not mean multiplication. This is not f times x. This is f of x. That's a special thing with function notation. This is f of x. And then over here, this is the rule for the function. So this tells me this function f has an input of x, and the rule for this function is that m times x plus b is equal to the output f of x. So we're going to take a look at what this looks like in a second. Sorry. First, we need to talk about a few things that I just mentioned. F of x does not mean f multiplied by x. And for any function f of x, the input of the variable is whatever is in parentheses right here. So f of x, x is the input variable. If it were f of y, y would be the input variable. Whatever is here tells me what the input is. And then just like with any other function, the values of the input variable make up the domain. The domain is numbers I could possibly put into the function. And then the output values make up the range. Those are the values I could possibly get out of the function. So here's how we use function notation. So let's say that we have this function. So we have g of m, and then we say g of 5 equals 7. What function notation tells us is it tells us if we take this function g and input 5, we get out the number 7. So if I know that it was g of m, g of 5 means that I put 5 in for m, and the output of the function was 7. So here's an example down here. I have h of p equals 3p minus 7. So h is the name of the function, p is the input of the function, this is the rule for the function. So if I want to find h of 1, so h of 1 is going to be equal to 3 times 1 minus 7. That's because 1 is what I'm inputting for p. That's what I have in here for the h of. This is h of 1, so 1 is what's being input for p. So I have 3 times 1, which is 3 minus 7, is negative 4. So this tells me h of 1 equals negative 4. And again, what this means is if I take this function h and I input the value 1, I get out negative 4. So this negative 4 is the output that goes with this input 1. And it also means, we're going to get to graphing soon, but this is an important distinction to understand about graphing. What it means is if I were to graph this equation, the point 1 and negative 4 will be on the graph, because if I input 1, I get out negative 4. So let's try it again here with h of negative 2. So h of negative 2, this would be 3 times negative 2 minus 7. So 3 times negative 2 is negative 6, minus 7 is negative 13. So again, this tells me something different about this function. It tells me h of negative 2, meaning if I plug negative 2 into this function, I will get out negative 13. And again, if I think about this graphically, it tells me that the point negative 2, negative 13 will be on the graph because this is the input and this is the output. So I'm going to leave this one open. When we get to class, we'll look back at this example if anybody has questions about it, and we'll use some different values to see if we can figure out h of some different values as well. So it's also helpful to use function notation when you have more than one function involved. The reason for this is, like I said before, you guys are probably used to seeing y equals to tell you a rule for an equation. So here's an example where I actually have two different cell phone companies. So what we're going to do is we're going to write a function that expresses how much I'll be charged by each cell phone company. So we're going to get into writing equations a little bit more later, but this is going to be our first example where we see an equation that we actually have to write. So when we write equations, one thing that we want to think about is what is the input value here? So when I read this, it says cell phone company A charges $30 to set up a data plan, additional $5 per gigabyte of data used. Cell phone company B doesn't charge anything to set up a data plan, but they charge $10 per gigabyte of data used. So when I read this, I think to myself, all right, self, what is actually changing? What's the variable that's actually changing that'll affect the amount of money that I pay? And that variable is the gigabytes of data used. So we're going to say that, let's just call it G. So G is going to be the gigabytes of data used. So what I want to do is I want to define two functions. I want to define A of G, and that's how much I'm going to pay company A. So money to company A. And then I'm also going to have B of G, and B of G is the money that I'm going to pay to company B. So the reason this is helpful is because within the context of this one problem, I have two different functions. One that tells me the amount of money that I pay to company A, and one that tells me the amount of money that I pay to company B. So first, let's look at company A. So A of G. So what I want to think about is how much do I pay per gigabyte of data used? And the answer to that is I pay $5 per gigabyte of data used. So for every gigabyte of data that I use, I multiply it by 5. So I have 5 times gigabytes of data, and that'll give me how much money I pay for just the data used. But I also want to keep in mind that I initially pay $30 to set up the data plan. So this function here, what this tells me is my input is G, so I input the gigabytes of data used, and using this rule, I get an output that tells me the total amount of money that I pay to company A. Now I can do the same thing for company B. So for B of G, this time I'm charged $10 per gigabyte of data used. So this is 10G, and there is no standard amount that I have to pay to set up the data plan. So this one is just 10 times G. The number of gigabytes that I use times 10 will tell me the amount of money that I pay to company B. So this function tells me if I input G, the gigabytes of data used, and use this rule, it'll output B of G, the amount of money that I pay to company B. So let's just say, for example, that I use 3 gigabytes of data. So if I use 3 gigabytes of data, if I want to find A of 3, I'm going to plug 3 in for G. That's 15 plus 30, so A of 3 is 45. B of 3 would be right here. I'm going to plug in 3 into B of G, so I get 3 times 10, which is 30. So if I use 3 gigabytes of data, company B is actually going to give me the better deal because I'm only paying $30. So what this means is if I use 3 gigabytes of data, I will pay company A $45. This means if I use 3 gigabytes of data, I will pay company B $30. So that is it for today's lesson. Today we talked about function notation, how to interpret function notation, and then especially we focus on the relation of function notation between input and output. Remember, the input is what is in there in the parentheses, and the output is the whole f of x, whatever the name of the function is of the input variable. So I hope you took some notes. Hope you come to class ready to learn and with some questions. And I hope to talk to you again soon. Have a fantastic day.